Hi Year 12, we've made it. We've finished Year 11 and we're beginning our Year 12 course. And this is the first topic, sequences and series. So let's start with this. Gauss was only 9 years old when his teacher asked the class to add all the numbers from 1 to 100. And it took him only seconds to find the answer. And I want you to think about this. I'm going to give you the answer at the end of the video. But how did he do it? Okay, let's start with some definitions. A sequence is a set of numbers written down in order according to some rule or pattern. And these are all sequences. Here we can see the pattern is we start at 1 and then we go up by 2. Here we've start at 2 and then we multiply by 2. Here are the square numbers, so 1 squared, 2 squared, 3 squared, 4 squared. And this is the Fibonacci sequence. Hopefully you remember that, where we get the next term in the sequence by adding the previous two. In a sequence, there is usually a relationship between the position of each term and the value of the term. And you may remember, perhaps not fondly, tables like this. And here we have the position of the term. So this is the first in the pattern, then the second, the third, the fourth, the fifth, and the nth term. And this is the value of the term. Well, this is the actual pattern, 1, 3, 5, 7, 9. And back in Year 7 or Year 8, you were asked to figure out what the value of the nth term was, or what was the expression that would generate this pattern. Now the good news is there's going to be a much easier way to do this, but it doesn't hurt us to revise this. So basically I want to know, what do I do to this number to get this one in each case? Now there is a bit of a trick to this. If your numbers are sequential here, your positions, which they are, then whatever this is going up by is the gradient. And this is going up by 2. And you remember from linear relationships that the gradient goes in front of the pronumeral. So it's going to be 2n, because it's going up by 2, plus or minus something. Now what we're going to do is just test out our pattern. So 2 times 1 is 2. How do I get to 1? I subtract 1. So that's going to be it, 2n minus 1. Now we should just check it and make sure it works. 2 times 2 is 4, take 1 is 3. Yep. 2 3s are 6, take 1 is 5. Yes, it is correct. Now what we can write is T2, for example, is equal to 3, or we could write Tn is equal to 2n minus 1. Here's an example. Find the first 5 terms of the sequence whose nth term is 153, take 4n. So the first term is going to be when n is equal to 1. So I just substitute in n equals 1. So T1 equals 153, take 4, which is 149. This is really easy maths. So T2 is 153, take 4 times 2, which is 8, is 145. This is a linear sequence. We can see that's just n to the power of 1. So once you see the pattern, you can continue it. But let's do one more. T3 is 153, take 4 times 3 is 12, which is 141. We can see that it's going down by 4 each time. So there's T4. And there's T5. A series is the sum of certain terms in the sequence. So for example, we can write S subscript 5 to mean the sum of the first 5 terms. We can also use sigma notation, and this does confuse some students, but this is exactly the same thing. It means find the sum of the terms in this sequence from k equals 1 up to k equals 5. Now the good thing about sigma notation is you don't have to start at term 1. Here you do. This S notation means the sum of the first 5. But we could write this in sigma notation. So this means the sum of the terms in the series from k equals 6 up to k equals 9. So you start at 6, then add 1, add 1, add 1 until you get to 9. Here's an example. Find the sum of the terms of 2n squared take away 1 from n is equal to 1 up to n is equal to 5. So we'll start with n is equal to 1 and just substitute it in. 2 times 1 is 2, take away 1 is 1. Now put 2 in. 2 times 4 is 8, take away 1 is 7. Putting 3 in. 2 times 9 is 18, take away 1 is 17. Put 4 in. 2 times 4 squared, so 2 16s, 32, take away 1 is 31. And then finally put 5 in. And that gives us 49, and adding them up we get 105. Let's finish off by answering that question from the beginning of the video. How do we add the numbers from 1 to 100? Well, here they are. Let's have a look at it. There is a pattern. Now, many of you know this, but for those of you who don't, have a look at this. What do 1 and 100 add to? 101. How about 2 and 99? It also adds to 101. How about 3 and 98? Yep, 101. And 4 and 97? Again, 101. In fact, all the way right to the middle, all of those pairs of numbers are going to add to 101. And there are 50 pairs of numbers. So the sum is simply going to be 101 times 50, which is 5050. Now in this topic, there are two specific sequences that we are going to study. We're going to look at arithmetic sequences, and they have a common difference. That means they go up or down by the same amount each time. Like this one, 2, 4, 6, 8 goes up by 2 each time. And the second type of sequence is a geometric sequence. They have a common ratio, which means we multiply by the same amount each time. And this one here, we're multiplying by half. And in the next video, we're going to look at arithmetic sequences.